Whoa, Wally.
OB, you made a hit, nigga.
What's up, y'all? My name is Willie J. Curry Jr., and welcome to The Light That Penetrates Open Eyes. The Light That Penetrates Open Eyes will consist of a series of essays on metaphysical psychology. All of these essays are original concepts of my own and backed 100% by facts. For all of you that are looking to develop some form of weightlifting routine, feel free to utilize what you see in this video. You're guaranteed to see results. Part 1 of The Light That Penetrates Open Eyes, Hierarchical Modularity by Willie J. Curry Jr. Brain modularity is the idea that the brain is composed of subnetworks that have distinct functions and connectivity patterns. Evidence of brain modularity in the empirical body of findings demonstrate that the brain is organized into semi-autonomous groups of neurons and brain regions that interact with one another through relatively sparse and long-distance pathways in the brain. Semi-autonomous is defined as acting independently to some degree. Identification of what a specific object is relies completely on multiple brain structures. This is one source puts it. One example of modularity in the mind is binding. When one perceives an object, they take in not only the features of an object, but the integrated features that can operate in sync or independently to create a whole. Instead of just seeing red, round, plastic, and moving, the subject may experience a rolling red ball. Binding may suggest that the mind is modular because it takes multiple cognitive processes to perceive one thing. The same source cites a theory that sheds light on mental processes when there's an interaction between faculties like memory, imagination, judgment, and perception. And if I might add, all of the above are common in just a single thought. Hierarchical modularity is brain modularity, but this type of brain modularity that I am describing is more consistent with the function of specific motor tasks, exhibited in response to a distinct stimulus to those of which we normally encounter, and is exhibited through homeostatic upscaling or upregulation. Even though we know that hierarchical modularity is brain modularity, I believe that it would be incumbent for us to distinguish this type of brain modularity apart from all others by ascribing the term hierarchical modularity to this particular type. And therefore, my concept of hierarchical modularity is the ability to withstand resistance when there's pressure. And it is completely original, simple, and gives us more of a comprehensive view as to the function of hierarchical modularity. I define resistance as protracting the time of a response / intervening with the term of another response. But we will mainly focus on resistance as intervening with the term of another response. I define pressure as the difference in the random aspect of time in a response. And therefore, hierarchical modularity is better defined as the ability to withstand intervening with the term of another response when there's a difference in the random aspect of time in a response. In order for me to expound on this concept of hierarchical modularity being the ability to withstand intervening with the term of another response when there's a difference in the random aspect of time in response, which is synonymous for the ability to withstand resistance when there's pressure, I will have to take you through the mechanisms of homeostasis. Homeostasis is defined as the ability to maintain relative stability and function as changes occur in our internal and external environment. We are delving into homeostasis because it's a mechanism that provides us with stages leading up to whereabout hierarchical modularity is exhibited. We begin where there's a vital connection in all of our processes being in tandem with the environment. And this is what I call the general quiescence of the visceral process, wherein the prime example of this would be air to breathing. Visceral to me means that which is essentially contained in the organ, which is good to have in mind to give you a better idea of what exactly a visceral organ is when learning which of our organs are. And this would be the heart to blood, lungs to air, digestive system to food, excretory system to waste, reproductive system to sperm cells and ovum, and circulatory tissues to blood, which distributes oxygen, nutrients, hormones, and etc. to the cells and organs of the body. So the function of every system of the body's processes are incumbent upon the structural interdependence of subsystems, when there is a dependency of one system on another, in so much as being indispensable in carrying out each of their own particular function. Homeostasis is the process through which these organ systems constantly adjust to internal and external changes to maintain stability. A change in our internal and external environment is called a stimulus. The response of any of the body systems undergoing homeostasis is to adjust the deviation back to a stable level, wherein the body's functions are kept within specific ranges. So now looking a bit deeper into this ability to maintain relative stability and function as changes occur in the internal and external environment brings us to the point where we've become so neurally developed and acclimated in capacity of this process in particular environments that the negative feedback to various forms of stimuli that we encounter become upregulated and downregulated, as well as inveterate responses of neural circuits that actively maintain a relative balance with external conditions via response. Exhibited here, no response intervenes with the term of another response, and even to the point wherein tied into connection with virtually every form of a stimulus that shares a particular characteristic of the environment is a response through which viability is seamlessly maintained according to its manner and relation. For example, the casual lack of concern for the smell of the air in a particular environment, to the familiar sounds of voices to the objects that we rest our limbs on, as well as the fluidity of our actions, all can occur at the same time as responses to stimuli that are inveterate within our neural circuits as well as up and down regulated, which displays how no response intervenes with the term of another response. But if the temperature of this place is extremely colder than usual, the temporal aspect of these inveterate as well as up and down regulated responses to stimuli are deferred and being exhibited where there is a dysregulation of body temperature control. This is resistance. The environment would be rendered one unfit to occupy in the above manner. But if the temperature of this place was not extremely cold, but one suitable to our personal comfort levels, these responses to stimuli that are inveterate and up and down regulated would be exhibited, because no response intervenes with the term of another response. Homeostasis is whereby no response intervenes with the term of another response. Again, homeostasis is attained whereby no response intervenes with the term of another response. These responses to stimuli are developed into neural circuits that are firmly established and display the most significant role in standard of the neural connections of our neural circuit activity, wherein we have become neurally acclimated to external stimuli. These are responses to stimuli that possess a fixed temporal pattern in our neural circuitry. Neural circuits are finely tuned to process information based on temporal patterns. So the concept of resistance is exhibited wherever our response to stimuli intervenes with the term of another response. And this is in terms of a response to stimuli that hasn't been made a part of our neural circuitry prior to stimulation, wherein there is neural circuit connectivity and mechanisms that maintain the function of neural circuit activity, even to the extent of being instrumental in the dynamic organization that enables the brain to react flexibly to different situations. A response intervening with the term of another response causes changes in the fixed temporal patterns of responses to stimuli within our neural circuitry and the inextricable neural circuit connectivity due to due to the difference in the usual function of our neural circuit activity. Just as one source puts it, homeostasis is a process by which neural circuits maintain relatively constant activity levels by balancing network excitation and inhibition and coordinating changes in circuit connectivity. Homeostasis is the active regulation of the dynamic adjustment within the system of the body's interdependent structure. No response intervening with the term of another response is the nature of this mechanism through which our body's processes are kept within a narrow range of a stable level. So we spoke about the general essence of a visceral process, wherein all of our processes are innately in tandem with the environment, to which the prime example of this is air to breathing. And there are many benefits sunlight has on the body through the skin. Sunlight is also needed for sight and so forth, but the point at hand is that if we look at internal stimulus, as in thought, emotion, thirst, and hunger, they are all an aspect of responses that render some form of balance in the vital connection there is between our processes and the environment. Therefore, these areas further substantiate even more so how innate all of our processes in tandem with the environment really are. Homeostasis enables all of our processes the capacity to become in tandem with the environment. Pressure is the difference in the random aspect of time and a response, and is exhibited through homeostatic synaptic upscaling and or what is termed upregulation, which is caused by a chronic reduction in the neuron's firing rate, wherein the brain responds to the reduced activity in a neural circuit with negative feedback, allowing neurons to increase their overall action potential firing rate. The occurrence of a difference in the random aspect of time and a response is not limited to the specific instance, but wherein there is by way of homeostasis established no response intervening with the term of another response, exhibited in our processes as responses to the various forms of stimuli that we are predisposed to, is terms in providing the basis for this particular outcome. But before we delve any further into this, it's imperative that we establish a greater understanding of sense. Sensory receptors are extensively structured throughout the extent of our internal and external organs, wherein they detect and process input from either our internal or external environment. Research shows us that sensory receptors are specialized cells that detect changes in the environment and convert these changes into electrical signals that can be processed by the nervous system. A source says the role of the nervous system in homeostasis is to detect and respond to changes in the internal and external environment of the body. The nervous system sends fast electrical impulses through nerves to the brain, which instructs an effector to react and return the body to a state of equilibrium. The nervous system is the major control system of homeostasis, and it functions from the cellular level to the whole body level. Sense detects changes. A stimulus is a detectable change in the physical or chemical structure of our internal and external environment. A detectable change in where no response intervenes with the term of another response. Feedback loops are employed to maintain homeostasis. There are two types of feedback loops. negative feedback loops, and positive feedback loops. Homeostasis is regulated by negative feedback loops and much less frequently by positive feedback loops. Negative feedback loops counteract a change and are marked by responses that bring a system back into the normal range of functioning. Positive feedback loops enhance or amplify changes which tends to move a system away from its equilibrium state and make it more unstable. A source says that homeostasis means to maintain body functions within specific livable ranges, adjusting to internal and external changes. Temperature, nutrient concentration, acidity, water, sodium, calcium, oxygen, as well as blood pressure, heart rate, and respiratory rate are some of the internal body variables that must remain within a certain range. When the body fails to maintain internal body variables within a certain range, normal function is interrupted, and disease or illness may result. These internal body variables are better known as physiological variables. Physiological variables that change are stimulus. Physiological variables are considered values because they determine the state of a system of the body and are essential for the function of the entire body. Physiological variables vary and change for various reasons that include physical activity and environment, but they must remain within a narrow range appropriate to a particular system, to which is maintained by way of homeostasis. There are sensors within every organ system of the body to measure the change of physiological variables. In most homeostatic mechanisms, the brain is the body structure that determines the normal range of a variable. Sensors detect changes in the physiological variable to which the body structure that determines the normal range of the variable responds to the stimulus received from the sensor by sending signals to effectors. A effector is a cell, tissue, or organ that responds to signals from the body structure that determines the normal range of the variable by providing a response to a stimulus, the physiological variable that changed. Effectors either oppose or enhance the stimulus in the form of negative and positive feedback loops. It would be pertinent to note that again, an effector is a cell, tissue, or organ that produces a physiological response when stimulated by a nerve impulse. Most commonly suited as an example of this would be muscles and glands. Muscles contract and glands release chemical signals to communicate and regulate the body's physiology. Let's consider another way of looking at feedback loops. And this would be an example of a negative feedback loop, which would consist of a receptor, to which is a sensory organ, a stimulus, to which is an action that evokes a response, and an effector, an organ that acts in response. So, an example of this is as follows: the receptor would be the eyes, the stimulus would be someone's shoes untied, the effector would be your finger and mouth wherein you point and speak to advise them that their shoes are untied. Essentially, there are other parts and element of different factors that are substantive in producing a feedback loop that can replace the ones used in this depiction interchangeably as examples in different scenarios, but of the same mode in direct portrayal of a feedback loop. Before moving forward, let's make note that a feedback loop is the part of a system in which the system's output is used as input in the future as a component in that which precedes an elicited response. Similar to how one source explains it on the topic of feedback loops, negative and positive feedback mechanisms. A feedback loop is a process where the output of a system is fed as input to, to the same system, which results in a continuous cycle of information or actions. And then it goes on to say an example of the feedback loop mechanism is homeostasis in different organisms. This is significant to consider in terms of how we view adaptation. Just think of the body's response to a stimulus in the environment. Just as every process is equal to where there is no other aspect wherein a difference can be made in the absence of its function in the structure of equilibrium in the body, the same principle applies in a response tailored to the fashion of a particular stimulus that is developed, cultivated, and meets the time and manner of an adequate response because there is no other aspect wherein a difference can be made in the absence of its function. We also see in the latter example of a negative feedback loop that feedback loops from a behavioral standpoint are conditioned and instinctive to which would require an association with external stimuli, as well as some form of a basis in correspondence with external stimuli. The domestic establishments of our early upbringing has played a significant role in laying the foundation for how neurally acclimated we become to the point of developing inveterate responses to the various forms of stimuli that we are predisposed to today. Here is where different customs, living conditions, language, values, habits, and attitudes play a part in molding us into the type of individuals that we are to become. Endogenous factors, factors originating within our genetic makeup that are passed down from one generation to another, are also very instrumental in how we become oriented to our surroundings and are exhibited in response to external stimuli. There exists a fluidity of our actions coupled with a casual lack of concern for various forms of stimuli that are exhibited and characteristic of these patterns of behavior due to the level of commonality within these environments that is displayed through an uninterrupted progress of the successive parts made in sequence of an objective or activity, as well as an uninterrupted progress from one objective or activity to the next. And the manner in which, say for instance, we unthinkably sit or rest our limbs on particular surfaces, as in walls, sinks, furniture, stoves, and etc., without ever occurring to us, without it ever occurring to us in a peculiar way. And the same would go for particular smells, sounds, and activity that do not occur to us in a peculiar way. We've been adapted to the point where we are negligent of certain aspects of a stimulus, as well as particular responses to stimuli. Unconscious processing of stimuli is developed in environments through actions that are consistently repeated when there is a high probability of them recurring again, and also through the natural occurring responses to particular sounds, light, temperature, or odor. The unconscious processing of stimuli applies to the various forms of stimuli that we are predisposed to. And this is exhibited by way of inveterate responses within our neural circuits, as well as homeostatic synaptic up and down scaling, wherein no response intervenes with the term of another response. A source says homeostatic synaptic scaling allows neurons to maintain their activity within a dynamic range, despite ongoing alterations in input activity, thereby ensuring normal propagation of signal throughout the neuronal network. This definition of homeostatic synaptic scaling clearly substantiates the concept of homeostasis being attained whereby no response intervenes with the term of another response. Associative memory is the ability to learn and remember the relationship between unrelated items. There's a common thread between learned behavior and associative memories that we can tie in connection to the development of the various forms of stimuli that we are predisposed to today. Homeostatic synaptic scaling plays a significant role in associative memory. For instance, when there is a unconscious processing of stimuli that corresponds and is exhibited in a particular manner in which something is done in a way that is negated beyond which there is an overall importance to bring ourselves to the point of a specific action. For example, when we're driving with one arm on the car door outside of the driver's side window and one hand on the steering wheel with the seatbelt on, there's a unconscious processing of stimuli in the form of associative memory exhibited in the scenario through our backs in the driver's seat, our arm outside of the driver's side window resting against the car door, and the seatbelts across our chest during the entire time that we are driving. The unconscious processing of stimuli is also displayed in the fluidity of action there is in managing particular tasks, more commonly exhibited in getting dressed, eating, riding a bike, walking, and typing, but not limited to these specific instances. The manner in which we carry out these particular tasks are less premeditated and once again more of an uninterrupted progress of these successive parts made in sequence of an objective or activity, as well as an uninterrupted progress from one objective or activity to the next. There are inveterate responses established between the basis of the various forms of stimuli that we are predisposed to and the environmental conditions and activity that encompass them. The random aspect of time in a response means that within the environmental conditions and activity that encompass the various forms of stimuli that we are predisposed to, responses are more readily employed at any given moment to any particular object or event. Homeostatic synaptic scaling is a negative feedback mechanism, which we can clearly attribute to acclimation. Again, homeosynaptic scaling allows neurons to maintain their activity within dynamic range, despite ongoing alterations in input activity, thereby ensuring normal propagation of signal throughout the neuronal network along the same lines. Another source simply says that homeostatic synaptic scaling allows neurons to counteract excessive or insufficient activity by down or upscaling all of their synapses by the same factor. Homeostatic synaptic scaling is a form of synaptic plasticity that adjusts the strength of all of a neuron's excitatory synapses up or down to stabilize firing. Homeostatic synaptic upscaling and downscaling refers to upregulation and downregulation. Upregulation is the increase in the number of cellular components in response to stimuli, through which is a process of increasing the response to a stimulus. As the source says, upregulation is a multiplicative increase in the strength of synaptic inputs to a neuron as a compensatory response to chronic reductions in the firing rate. For example, when we're in a dark room, our eyes can be upregulated to help us see better in low light conditions. Fear can be more readily upregulated than downregulated due to the increase in physiological responses like pupil dilation and heart rate. Upregulation is also exhibited in what is known as irascibility, where someone is easily angered due to some form of impatience or an annoyance. The inveterate response is established between the basis of the various forms of stimuli that we are predisposed to and the environmental conditions and activity that encompass them. Display the fluidity of action by way of negative feedback made possible through homeostasis in the form of responses that are more readily employed at any given moment to any particular object or event. Downregulation is the process of reducing or suppressing a response to a stimulus in the sense of adaptation, where the brain responds to chronically elevated activity in a neural circuit with negative feedback, allowing individual neurons to reduce their overall action potential firing rate. Downregulation is displayed through stimuli that we are in response to and or physical contact with without it ever occurring to us in a peculiar way. For example, our hearing can be downregulated to help us focus on our thoughts or other things in an environment. Once again, both upregulation and downregulation display how homeostasis exhibits no response intervening with the term of another response by way of neurons counteracting excessive or insufficient activity. Homeosynaptic scaling is characterized by a development of tolerance, increasing the response speed of receptor systems, the ability to accurately process time varying input, tight and efficient input output coupling, which ensures synchronous information processing, improving frequency processing. This is in terms of threshold stimulation at frequencies within a neuron's physiological range, wherein a stimulus produces a full response of the excitable cell. Neurons are referred to as excitable cells. Research also shows that downregulation is a phenomenon that makes systems more resilient in responding to external perturbations, thus improving the stability of the system's resting state, which is a big point that coincides with how, through homeostasis, our processes exhibit no response intervening with the term of another response. What brings us to the point of hierarchical modularity is homeosynaptic upscaling or upregulation, wherein the cause of upregulation is a difference in the random aspect of time in a response. Upregulation typically involves inveterate responses, whereas hierarchical modularity forms adequate responses to a distinct stimulus than that of which we normally would encounter, one that could quite intervene with the term of another response. It's safe to say that hierarchical modularity is an element of upregulation. Upregulation and hierarchical modularity are not both the ability to withstand intervening with the term of another response when there's a difference in the random aspect of time in the response. When upregulation alone, by way of an inveterate response, does not completely address a stimulus that intervenes with the term of another response at disposal. The ability to withstand intervening with the term of another response is exhibited only with hierarchical modularity because its very role as a function is to render to term an adequate response to a distinct stimulus that holds the potential of intervening with the term of another response altogether. But before we delve deeper into hierarchical modularity, it would benefit us to have an idea of the brain's hierarchical organization of the body. The brain has a hierarchical organization that extends from the cellular level to the cortical level. And hierarchical cortical organization is found in all sensory systems, in the reward system and in the memory systems. The primary sensory areas are the primary cortical regions of the five sensory systems in the brain. That is to say, taste, olfaction, touch, hearing, and vision. The reward system refers to the mesocortical limbic neural circuit, which is composed of brain structures that are responsible for mediating the physiological and cognitive processes of reward. Reward is a natural process during which the brain associates diverse stimuli, that is to say, substances, situations, events, or activities, with a positive or desirable outcome. And then we have the cortical hippocampal system, a network of brain regions that play a crucial role in declarative memory. Declarative memory can be divided into episodic memory, commonly defined as the memory for personal events and experiences, and semantic memory, the memory for facts or general knowledge. The hierarchical organization of the human body ranges from cells, tissues, and organs to organ systems. The brain is responsible for regulating and coordinating the functions of the body's tissues and organs. There is an inevitability in the significance of the specific function that every body part has that balances the function of other body parts, wherein the lack of the specific function compromises the terms of equilibrium. So, with this hierarchical organization of the body, every part of the body has a specific function that balances the function of other parts of the body throughout the extent of the entire structure of equilibrium. All of these processes are interrelated, and no part of the body, from the smallest cell to a complete body system, works in isolation. What serves as a point of reference as to which processes can be deemed hierarchical is the fact that these processes have to be executed at a particular time within an exact time frame to maintain equilibrium. There is research that ties executive cognition in with the hierarchical organization of the body. Executive cognition of the brain exhibits the importance of this temporal aspect being exhibited through its function. For instance, the way inhibitory control makes us stop and consider an alternative and aspect of resisting an impulse. This would be deemed a hierarchical mechanism, wherein there is an inevitability in the significance of these executive cognitive processes, an inevitability that compromises how every body part has a specific function that balances the function of other body parts throughout the extent of the entire structure of equilibrium, wherein all of these processes have to be executed at a particular time within an exact time frame. So stopping to consider an alternative and aspect of resisting an impulse enables us the ability to fulfill this standard. Working memory is another executive cognitive function that allows a person to temporarily hold a limited amount of information at the ready for immediate mental use. It is essential for learning, problem solving, and etc. It helps the brain organize new information for long term storage. An example of this would be holding a number in mind while doing a math problem in one's head, or keeping multiple concepts in one's head in order to combine them. Another thing to note is each process has a linear path in fulfilling the temporal aspect of this standard. In some processes, as the executive cognitive functions of the brain are at length of narrowing down the temporal aspect of processes to the margin of all processes being executed at a particular time within a exact time frame. Hence, interpretably, all processes are conducted in the most direct, positive, and accurate manner. Functionally, The nervous system is hierarchical. The hierarchy consists of effectors in different levels of information processing and integration by way of nerve cells, as well as the spinal cord, the brain stem, and forebrain. And again, the nervous system is the major control system of homeostasis. Homeostasis is the process of maintaining a stable internal environment. The human body processes stimuli in a hierarchical manner, which is exhibited with homeostasis as one source speaks of how the body monitors its internal conditions such as body temperature, blood pressure, and nutrient levels, and maintains them within a normal range. We can easily conclude that the various forms of stimuli that we are predisposed to are maintained in a hierarchical manner if we also take into consideration how neurally acclimated we are to these responses to stimuli. Stimuli that become a part of negative feedback mechanisms, such as homeostatic synaptic upscaling and downscaling, and also responses that are more readily employed to particular stimuli, because the temporal aspect of these processes are executed at a particular time within an exact time frame that enables us the ability to fulfill the standard of every part of the body having a specific function that balances the function of other body parts throughout the extent of the entire structure of equilibrium. Along with this, the brain processes information from different sensory receptors. Stimuli is a factor that plays a crucial role in the development of brain networks, aside from genetics. By way of stimuli, feedback loops are a common feature of neural circuits. Feedback loops return the body to homeostasis in response to changes in the optimal conditions for the body to function, wherein we become neurally acclimated to various forms of stimuli. Multiple neural circuits interconnect with one another to form large scale brain networks. Networks of the brain are systems of interconnected neurons that span different levels of organization and function. There are several core networks of the brain that are involved in different cognitive and sensory processes, such as salience, attention, sensory motor, and visual. Hierarchical modularity refers to the organization of brain networks into modules within modules. Modules mean subnetworks embedded within larger networks. Therefore, hierarchical modularity can be defined as subnetworks within large brain networks that are part of the subnetworks of other large brain networks. These subnetworks are functionally connected to and therefore are interrelated to a specific brain network. Brain networks route signals and process information, which generate a response. I've read a module comprises multiple submodules, and the function of a module is to integrate and contextualize the more specialized functions of its submodules, which brings home the point and substantiates how there are many subnetworks from other brain networks within the subnetwork of a specific brain network. Contextualize means to put something into context with the situation in which it exists or happens. I've also come across a source that elaborates on the importance of modularity, wherein it says modularity accelerates the emergence of complex systems from simple systems by providing stable intermediate forms, component modules, that allow the system to adapt one module at a time without risking loss of function in other already existing modules. and from another source speaks of the importance. Also, wherein it says there are several general advantages to modular and hierarchical modular network organization, including robustness, adaptivity, and evolvability of network function. What I gathered from all of this is that the coordinated activity of these neurons that make up these subnetwork neural connections within another subnetwork of a large brain network act as forms of functional modular components that enable a specific brain network the ability to consolidate an adequate response. Hierarchical modularity is characterized by a response to a distinct stimulus to those of which we normally encounter and displays the maximum efficiency of a specific motor task to which is performed automatically with little to no conscious effort. And this is usually exhibited in speech and behavior. The only mental happening that gives us a better idea of this, due to the lack of conscious effort that is involved and or exhibited, is displayed with what is termed criticality. Criticality is a concept in neuroscience that refers to a dynamical state between order and disorder, where the brain operates at the edge of chaos. As one source puts it, criticality is the singular state of complex systems poised at the brink of a phase transition between order and randomness. This occurs at particular moments in the manner of us suddenly reacting to something unexpected and being more poised than usual. Again, there's a lack of conscious effort involved and or exhibited. In conclusion, this has been my essay on hierarchical modularity being the ability to withstand resistance when there's pressure, which also means the ability to withstand intervening with the term of another response when there's a difference in the random aspect of time in the response. Because resistance means intervening with the term of another response, and pressure means a difference in the random aspect of time in a response. I found this topic important to expound on because, well, a while back, someone shared with me that the only high powered instrument that our ancestors had in antiquity was their brains. And modularity automatically took my mind to how they built the pyramids after a while of experiencing it and considering all of the feasible ways that the pyramids could have been built, with how much of a mystery that it is still today. I see it as a mental power or ability that can be harnessed to our maximum degree of potential with all of the right elements aligned as to the knowledge of the mind and body. Hierarchical modularity is exhibited through upregulation. The belief of sexual abstinence slash continence slash self abnegation, I believe, was a common practice in these times, which increases physical strength and endurance. It is common for upregulation to increase the use of physical strength, and hierarchical modularity can play a significant role in this. Also, sexual abstinence along with upregulation could have quite possibly been instrumental in the construction of the pyramids. Another thing to note is how we come up in a time where interpersonally it's common to experience individuals that shake their head no as a gesture that indicates how something may not be the way that it seems, or to block out anything that may occur to their mind that throws off their focus. In both cases, after a while in doing this, we begin to experience the circuits of neural networks through the response to stimuli. And by way of effectors, just as a source that I cited in the beginning puts it, a feedback loop is a process where the output of a system is fed as input to the same system, which results in a continuous cycle of information or action. So, in a nutshell, we're influencing the terms of the output by way of suggestion. In the near future, I will be putting out more literature on the brain, pineal gland, the heart, solar plex, and other various topics that will give us a means in developing a practical approach towards the more advanced methods of human potential. Might I add, the best way to look at the subnetworks within large brain networks that are a part of the subnetworks within other large brain networks that display hierarchical or brain modularity is in comparison to how every system of the body is a subsystem, wherein there is a dependency of one system on another, in so much as being indispensable in carrying out each of their own particular function. The Will by Willie J. Curry Jr. In my search to define the will, I began with my own original concept of it, which was force and response to change in the order of equilibrium. But further into this essay, we will learn that it is more so the ability to supersede the response. The fundamental principle of biomechanics is force causes movement. Ironically, in physics, this would be an unbalanced force. Let's take, for instance, these examples. Receptors in the walls of the stomach sense the absence of food, causing a reflex generation of waves of electrical activity in the enteric nervous system that travel along the stomach and small intestines and lead to hunger contractions that result in the action of eating. Thirst sensation is stimulated by an increase in plasma osmolarity. With increases in plasma osmolarity, water will flow out of the cell, causing it to contract. And when enough water leaves the cell, it will not be able to perform essential chemical functions. When the bladder is full, it sends signals to the brain through the pelvic nerves, which creates the urge to urinate. For most people, the bladder expands when it fills up like a balloon. Nerves in the bladder will detect the expansion and send a signal to the brain, letting it know that the bladder is full. As the waist fills the rectum and expands the rectal walls. Stretch receptors in the rectal walls stimulate the desire to defecate. Adenosine controls the sleep wake cycle or acts as an homeostatic regulator of sleep. Adenosine builds up during the day while we are awake. As the brain naturally produces more adenosine throughout the day, a person's need for sleep increases. Adenosine is broken down over the course of the night. This results in lower levels of adenosine in the morning. Yet, in response to darkness, melatonin prepares us for sleep. And as we are exposed to more light, such as the sun rising, our bodies release a hormone called cortisol. Cortisol naturally prepares our body to wake up. Smooth muscle cells are the most abundant cell type in blood vessel walls. Smooth muscles contract and dilate, which are exhibited through vasoconstriction and vasodilation. Vasoconstriction is the narrowing of blood vessels, or when blood vessels contract, and vasodilation is when blood vessels dilate or expand. Adenosine is a neurotransmitter. Melatonin is a hormone. Serotonin is both a hormone and neurotransmitter. All of these chemicals have been found to have vasoconstrictive and vasodilator effects. Balanced forces are those in equilibrium. The exact point of wherein there is force in response to change in the order of equilibrium correlates with two forces with equal magnitude in opposite direction of each other that cancel, which in physics is said to be balanced forces. In connection with my concept of the will, I'm looking at how two forces with equal magnitude in opposite direction of each other cancels, ties in with the point wherein the change in the order of equilibrium starts and completely ends due to a given response. The first force would be initiated by the change in the order of equilibrium, and the second force, in response to the change, would be when we will exhibit what I initially deemed as the will, and therefore force and response to change in the order of equilibrium. And this concept, as in reality, the force and response to change in the order of equilibrium is always in action. Let's delve a little deeper into this concept of the will. Behavior is defined as the change in the activity of an organism in response to a stimulus. Balance is the subjective value assigned to sensory stimuli, which determines subsequent behavior. There's a critical importance of balance processing for survival. Stimuli with negative emotional valence are especially apt to influence perception and action because of their crucial role in survival. One source explains how. Some environmental stimuli have innate valence, such that No prior experience is required to have emotional responses to them. Other stimuli are initially neutral and require learning to form associations between these conditioned stimuli and their motivationally significant outcomes. Emotional feelings arise from the integration of concurrent activity in the brain structures and circuits. Negative or positive emotional valence. Chemicals of the body that are concomitant of this negative and positive valence act as neurotransmitters in the brain and hormones that are released directly into the bloodstream. For example, dopamine, endorphins, serotonin, and oxytocin. With neurotransmitters, a target cell can be another nerve cell, a muscle cell, or gland cell. The role of neurotransmitters is to carry chemical signals from one nerve cell to another cell. In neural circuits, neurotransmitters play a crucial role in transmitting information between neurons. Emotional arousal involves changes in the activity of the visceral motor of the autonomic nervous system. The visceral or autonomic nervous system controls involuntary functions mediated by the activity of smooth muscle fibers and glands throughout the body. This is why there are increases or decreases in heart rate, breathing, sweating, cutaneous blood flow, that is to say, blushing or turning pale, piloerection, that is to say, goosebumps, accompanying various emotions. These integrated groups of anatomical structures of the visceral motor system functioning together are produced by way of stimulus response. Overall, internal visceral states are the cornerstone of motivational behavior. One source says emotion is closely linked to motor activity. Both are mediated by the autonomic nervous system and is thought to motivate a behavioral response, which further substantiates this concept of the will, which renders it force and response to change in the order of equilibrium. Though reflex allows for a quick and involuntary reaction to a stimulus under the control of the spinal cord without involving the brain, which arises from receptors in the skin or muscles that activate spinal motor neurons to evoke contractions connecting from the spinal cord directly to skeletal muscle. Here, force in response to change in the order of equilibrium is still displayed, but not in the same manner that is described in the latter examples. This is what caused me to believe it was something completely different and to go over my original concept of the will, which is the ability to supersede the response. Now, let's examine the facts more accurately. The will has been defined as the mental faculty by which one deliberately chooses or decides upon a course of action. It has been defined as fixed or persistent intent or purpose. Very similarly, it is also defined the mental power used to control and direct your thoughts and actions, or a determination to do something despite any difficulties or opposition. My insight into the will began with noticing the inevitability of not always being able to render to term an adequate response to an internal drive slash physiological need, as in hunger and thirst when they occur, though there are more, in the manner of subsistence when we proceed to do things beyond any of these particular points in time. This is where I began developing my idea of the will being the ability to supersede the response. The will is the ability to supersede the response, and what is meant by this actually is exhibited in the inevitability of not always being able to render to term an adequate response to an internal drive slash physiological need, as in hunger and thirst when they occur, and yet proceeding to do things in the manner of subsistence. But more accurately, if, say, for instance, in proceeding to do things in the manner of subsistence, we are resisting impulses suggestive of not completing certain tasks due to insufficient energy from not eating or drinking, to which our adequate response is needed to function optimally. In this case, three things happen. And before I do read these 3 points that are in numerical order, I want to first make it clear that yes, I believe these particular happenings do take place in some form of reality in the manner to which I've explained. But since I've yet to make the connection in the information that substantiates that it does in this essay, it is completely philosophical. And also, yes, these 3 points I believe are exhibited in the above example, but are not a direct portrayal of the will or define it. We will define the will by its actual function of a brain mechanism shortly. I felt that in my study and meditations on the will that these 3 points were instrumental in giving me an idea of the will, and still are imperative to have in mind, with the way they can serve a significance to how the function of another process operates as well. Number one, there's a capacity over the lack of time in capacitating a function. That is to say, as we proceed to do things, and every response capacitates a function. Number two, which establishes a capacity of a time in the manner in which gives precedence to a specific function. Number three, the aversive aspect of the response becomes more apparent in that which is evoked in the immediate attention of our awareness. Aversion means the avoidance of a thing, situation, or behavior because it has been associated with an unpleasant or painful stimulus. Now, again, the will has been defined as the mental faculty by which one deliberately chooses or decides upon a course of action. Wherein we exhibit the will is in specific instances wherein we resist impulses. The latter example of not being able to render to term an adequate response to an internal drive slash physiological need, as in eating or drinking, when they occur, yet we proceed to do things at these times, undergoing impulses that prompt us to respond to the fatigue of insufficient energy in the manner of not completing certain tasks, correlates with these 3 points in sequence. By refraining and proceeding to do something different. There's a capacity over the lack of time incapacitating a function. And every response capacitates a function. One source states human will refers to the human capacity to actively decide what to do instead of reacting automatically to stimuli. Again, there's a capacity over the lack of time incapacitating a function. An example of this would be wherein an individual is on a diet and has to refrain from eating certain food when they suddenly begin to crave for a chocolate candy bar, but instead chooses to eat a salad. There's a capacity over the lack of time in capacitating a function, and therefore the will is the ability to supersede the response. Both instances are prime examples of what is termed inhibitory control. Inhibitory control is the most significant aspect in defining what is considered will. And before moving forward, might I add that even the inevitability of not always being able to render to term an adequate response to an internal drive slash physiological need, as in hunger and thirst, when they occur, and proceeding to do things in the manner of subsistence, displays a capacity over the lack of time in capacitating a function. Inhibitory control is defined as the ability to suppress or stop thoughts, feelings, or actions when they are unlikely to accomplish valuable results. One source says inhibitory control involves controlling our automatic urges, that is to say, attention, behavior, thoughts, and emotions, by pausing, then using attention and reasoning to respond appropriately. Inhibitory control involves our ability to think before we react. Another says inhibitory control refers to the ability to suppress prepotent actions when they are unlikely to accomplish valuable results. Prepotent actions are defined as actions that are strongly triggered by the environment and so tend to be carried out unless intentionally avoided. Prepotent response is defined as the response that has been primed to occur through reinforcement, repeated use, habit, or reflex. A source says inhibitory control is a cognitive process that allows an individual to inhibit their impulses and natural, habitual, or dominant behavioral responses to stimuli in order to select a more appropriate behavior that is consistent with completing their goals. It is also known as response inhibition, and it is considered an executive function. Self control is an important aspect of inhibitory control. For example, successfully suppressing the natural behavioral response to eat cake when one is craving it while dieting requires the use of inhibitory control. Inhibitory control is a executive function of the brain. Executive functions are a set of cognitive processes that include working memory, emotional regulation, self-monitoring, and etc. Cognitive processes are controlled by the brain. I had to make light of this to substantiate how inhibitory control is an actual basic brain mechanism of the particular topic that we are expounding on. The prefrontal cortex, caudate nucleus, and subthalamic nucleus are known to regulate inhibitory control cognition. Inhibitory response mechanisms are not limited to humans, but is an innate function in the processes of other living organisms as well. With regards to being able to render to term an adequate response to an internal drive slash physiological need, as in eating or drinking when it occurs, but proceeding to do something in the manner of subsistence. Hunger and thirst is a natural response to the body's need for energy and nutrients. So, most commonly, we will experience in the lack of not eating or drinking, resisting the impulse to give up on completing certain tasks that stems from fatigue due to insufficient energy, by instead choosing to further engage in other goal oriented activity. This displays inhibitory control or will, just as deciding to not eat a chocolate bar while we are on a diet when we begin to crave for one. Again, the will is the ability to supersede the response. And yes, the will is exhibited every time we resist an impulse, which is exhibited by way of inhibitory control. And this last point, I want us to consider stimulus response coordination. The new responses, touching base with the functions that these responses capacitate, are in contrast with how the established stimulus response system is coordinated, which takes place while there is a lack of time incapacitating a function that's not being rendered to term altogether. This is why we become more and more immune over time to these changes. The stimulus and the response ramifies the stratification of the stimulus response coordination, or how the stimulus response system is coordinated. As one source puts it, coordination is the process by which various organs work together in a systematic manner to produce a response to the stimulus. What is widely prevalent in the scenario is how no response affects the equilibrium, wherein it limits the range and capacity of a function because every response capacitates a function. So it's difficult to proceed in the manner of action, wherein the ability to is dependent on interconnected parts working together. This is exhibited responding to impulses that are derived from fatigue due to insufficient energy, from not eating that are suggestive of not completing certain tasks, with the resilience to still engage in goal oriented activity. Now, in relation to this, the degree of specified characteristics like stimulus speed, intensity, and duration can set an elicited response apart from those of which are given term by way of how the established response system is coordinated. due to there not having been any response to these distinct degrees of stimulus speed, intensity, and duration, affecting the equilibrium to the point wherein at present it limits the range and capacity of a function to inhibit a response. My hypothesis is that this takes place with spiking neurons. Spiking neurons are neurons that fire action potentials in a rapid and irregular manner. Action potentials are nerve impulses. Nerve impulses are caused by stimuli. I came across a source that says the spike output of neurons often appears stochastic, meaning that the same stimulus output can cause a variable spike output. Most biological neurons exhibit stochastic and spiking action potentials. These spikes are generated when the neuron's membrane potential reaches a certain threshold, which coincides with the rate coding model of neural firing communication, a widely accepted model in neuroscience that states as the intensity of a stimulus increases, the frequency or rate of action potentials or spike firing increases. On the other hand, a stochastic neuron is a type of neuron that incorporates a randomness into its behavior, as another source further substantiates. A certain degree of stochastic behavior is, in fact, observed in biological neural networks. Neurons may spontaneously become active without a external stimulus, or if the synaptic or if the synaptic excitation does not exceed the activation threshold, to which is a consequence of the random emission of neurotransmitters at the synapses. And that is to say, the spontaneous release of neurotransmitter. And this would be in regards to stochastic neurons. The point that I'm making here is that there's lack of a response in both scenarios that limits the range and capacity of a function, just not in the same manner. And every response capacitates a function. So in the first scenario, no response is rendered to term altogether, wherein there's a established system of stimulus response coordination, which limits the range and capacity of a function in the sense of it being difficult to proceed, wherein the ability to is dependent on interconnected parts working together as every response capacitates a function consistent with processes in equilibrium. In the second scenario, there has not been any response to these distinct specified characteristics of stimulus speed, intensity, and duration, affecting the equilibrium to the point wherein at present it limits the range and capacity of a function to inhibit a response. This is exhibited with spiking action potentials. Its significance to the topic of the will is that these instances limit the range and capacity of a function to inhibit a response. The latter example displays the will in the manner of resisting impulses, suggestive of not completing certain tasks due to insufficient energy from not eating, yet still engaging in goal oriented activity. The will has been a term that has been used loosely in many professional fields of study, forms of literature, and etc. So I felt it was very important to establish a more accurate view of it. I began abstractly, and turns out I was initially correct. The ability to supersede the response was my first idea of the will. After a inconsistent aspect unfolded of the will being force and response to change in the order of equilibrium, I returned in my hopes to define it to the idea of my former concept, which was accurate, and how it correlates exactly to inhibitory control and executive cognitive function of the brain. And I believe we all need to be clear on this, just to remove any fathomable aspect of how to define it. I believe spiking action potentials are at the root of the innuendo inflections and increase in the stimulus due to negatively repressed thoughts, feelings, and actions. The instances where we experience innuendo inflections actually program us, in many cases, as far as we can gauge the intent of the individuals in which this occurs. And might I add, in many cases, this is something that is extremely difficult to control ourselves in an interpersonal setting. Hopefully, this will give us a better idea of what is actually happening. What also programs the mind is having to settle with the things that we have no choice but to accept. Given situations and circumstances like this, every response capacitates with a function. And where there's a lack of a response that capacitates a function, the established stimulus response coordination changes, wherein there are responses that supplant the former established responses, to the point where the concept of different forms of behavior and personality characteristics that we refuse to accept or be associated with assume the existence of the ones more in standard of the characteristics and principle of who we really are, due to the lack in the ability to sustain the concept beyond the feasibility of what we think in comparison to anything that we are actually experiencing. Might I add, the best way to look at the subnetworks within large brain networks that are a part of the subnetworks within other large brain networks that display hierarchical or brain modularity is in comparison to how every system of the body is a subsystem, wherein there is a dependency of one system on another, in so much as being indispensable in carrying out each of their own particular function. This is a preview of my essay called Source Data Engineering by Willie J. Curry Jr. Source data engineering is the blueprint of the engineering in all that exists, and how we, in the sense of apotheosis, engineer our true human potential. In this preview, the only correlation that I will make in aspect of source data engineering is of how the solar system was formed, though I will tie it into another process of the mind and body when this essay is released. At a later point, once a substantial amount of research is compiled in accurate detail on the various topics of literature that I will release only then will I be able to make complete sense of how to engineer our true human potential. As the story goes, we have the neutral degree and value. The neutral degree exacts no limitation in its potential of becoming equable to anything. Value is a distance marked by no stretch of time. Value, a distance marked by no stretch of time, is too far ahead of the neutral accomplishing becoming equable to it. So much that the infinitude of there never being a possibility is exact to point, and is rigidly set into the neutral structure, and thus ability to function any further. Therefore, resistance is displayed through value. There's resistance displayed by the neutral, also wherein it will never quit, but yet continue to proceed in trying because this is a point. So the neutral was stopped, but the neutral is ramifying the stratification, and with time, the neutral's resistance reaches a height that's higher than the integral. So it's equal in resistance, at this point reaching a height that's higher than the integral. Resistance means that something inside of both the neutral and value is absolute, meaning nothing could take away from the complete nature of its observance in the element that it exists in another by effect. At this point, the neutral has become equable to value. Then value reaches a rate that lapses back forward because it equals the resistance therefrom, being above the point of the limitation. The only thing is that the gain is incremental, because the neutral has already acquired a range of becoming equable, and an incremental gain continues, wherein the neutral becomes more and more equable to value, with value consistently reaching a rate that lapses back forward, equaling the resistance, and therefrom being above the point of each limitation until the neutral becomes equable to value's furthest extreme. The formula and measure of source data engineering is as follows. Number 1, neutral degree, difference per rate. Number 2, high rate, value per rate. Number 3, the terminal point, rate per value. Number 4, low register, value per difference. One of the most common theories of how the solar system was formed equates to the story of source data engineering, as well as the formula and measure of it, beginning with a star that stops burning its own fuel, which equates to the stop in the story that is to say the neutral being stopped by value from becoming equable to it. Gravity then causing the star to explode equates to the rate of the neutral, with it reaching a height higher than the integral, and thus becoming equable to value. This happening is a depiction of difference per rate. A nearby gas cloud is destabilized by the shock wave of the explosion. This expresses value per rate, value reaching a rate that lapses back forward, therefrom the neutral being equable to value, which causes the gas cloud to collapse, wherein gravity and angular momentum flatten the cloud into a swirling disk, wherein the center molecules crashed together the tightest, and a protostar revved up to incredible pressures and temperatures that become the sun at the center of our solar system, which depicts rate per value, wherein gravity acts again in nature of this process. And then value per difference is exhibited in these sequences further that unfolds more and more into the proper alignment of the spirit of existence that we know as the solar system today. Thank you for taking the time to listen to The Light That Penetrates Open Eyes. These essays will always be on metaphysical psychology. What I aspire to embark in time is an age where the technological advancement is human potential. My next essay will be source data engineering and another that I haven't quite decided on yet. You can contact me by way of Instagram or Facebook. Both The Light That Penetrates Open Eyes. I would appreciate any contributions that anyone has to offer. My cash tag is $high positivity. Thank you for your time. Until the next time, Willie J. Curry.